Okay, hello everyone in a new video. So we have reached part 3 of chapter 3, which is the DC voltage in the second unit of electricity. So in this part we are going to solve some exercises as a direct application on what we have explained on parts 1 and 2. Then let's start by exercise number 1. They are telling me consider an electric circuit consisting of two lamps L1 and L2 connected to a DC voltage source such that UPN is equal to 12 volts. A voltmeter is connected to the lamp L2 as shown in document 1. They mentioned the document, so now I can use it. Given that UAB is equal to 4 volts, K is a closed switch. Number 1. Always whenever solving such type of exercises, it's a good habit to write the given voltage on the electric circuit. Here we know that the voltage of the battery is given by 12 volts and the voltage UAB is given by 4 volts. The voltage UAB which is across the lamp L1, so this is 4 volts. Now in number 1 they are telling me UPA is equal to 0, justify. Here across P and A we have a connecting wire and we know that the voltage across a connecting wire is 0. Then let's write down the voltage across a connecting wire is 0, which means UPA is equal to 0. And now in number 2 they are telling me UCN is equal to 0. Across C and N we have a closed switch and we know that the voltage across this closed switch is 0 because it acts as a connecting wire. Now the voltage across a closed switch then in this case we have UCN is equal to 0. And now in number 3 they are telling me deduce UBC, which is the voltage across the lamp L2, and the word deduce means that we need to use the part just previously before in order to determine the voltage UBC. In parts 1 and 2 we have justified that the voltage across P and A and C and N is equal to 0. So whenever they ask me about the voltage across a certain branch, this means that we might use these values later in order to calculate the voltage across another branch using the law of addition of voltages. And here if we apply the law of addition of voltages, always in physics we need to mention the law that we are using, so usually they give a half a mark for this statement for the law of addition of voltages. Now how do we apply this law? Always on the left we start by writing the voltage of the battery which is given by UPN, and on the right we will go over the voltages of different electric components or all electric components in the given electric circuit. Then let's start with the point P. From P we'll go to the point A, then from A we will go to the point B, then from B we'll go to the point C, and from C finally we go back to the point N. So notice that here on the left hand side I have started with the point P, and on the right hand side I have also started with the point P. On the left hand side I have ended with the point N, as well as on the right hand side I have ended with the point N. So by this we make sure that the law that we have used is correct, and notice that each letter here I have inserted, or each point I have inserted it twice. Okay, so we have AA, BB, CC. Then we know that the value of UPN is equal to 12 volts. UPA is equal to 0, justified. Now we aren't okay. UAB is equal to 4 volts given. UBC that we need to calculate, and the value of UCN is equal to 0, justified. This gives us that 12 is equal to 4 plus UBC. So UBC is equal to 12 minus 4. Since 12 is in volts and 4 is in volts, then the value of UBC will be in volts, which is given by 8 volts. Then the value UBC is equal to 8 volts. And now in number 4, they are telling me specify the voltage measured by the voltmeter. Okay, so here UBC is equal to 8 volt. Let me write it on the electric circuit. So here the voltmeter is measuring the voltage across the lamp L2, which is given by 8 volts. Therefore, the voltmeter will indicate either plus 8 volts or minus 8 volts, and this depends on the COM terminal. Notice that here the COM terminal is connected to the negative pole of the battery, therefore the voltmeter will indicate positive reading. Then let's justify that since the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading, which is given by plus 8 volts. Then this is it for exercise number 1. Now in exercise number 2, they are telling me document 2. They mentioned the document, so now I can use it. Shows an electric circuit consisting of 3 lamps, L1, L2, and L3. The lamps are connected to a battery of voltage GPN is equal to 10 volts. I repeat always when solving such type of exercises, it's a good habit to write the given voltage on the electric circuit. So the voltage GPN of the battery is given by 10 volts, and an ammeter A that measures the current traversing the circuit. Here the ammeter A is measuring the main current in the electric circuit. The switch K is closed given that UBC is equal to 6 volts. So the voltage across the lamp L3 is given by 6 volt. I1 is equal to 0.5 amperes. And the value I2 is given by 0.25 amperes. The ammeter A is of negligible resistance. Now in number 1, they are telling me UCN is equal to 0, justify. Notice that across CNN we have a closed switch, and always the voltage across a closed switch is 0 because it acts as a connecting wire. Then let's say the voltage across a closed switch is 0 because it acts as a connecting wire. This means that UCN is equal to 0. Now in number 2, they are telling me the voltage GPA across the ammeter is 0. We know that always the voltage across the ammeter is 0 because it is of negligible resistance. Then let's write the voltage across an ammeter is 0 since it is of negligible resistance, which means that UPA is equal to 0 volts. And now in number 3, they are telling me calculate the voltage UAB. So the voltage UAB, which is across lamps L1 and L2. Notice that in parts 1 and 2, they have asked me about the voltage across a certain branch in the electric circuit. So we always should keep in mind that we might use these voltages later on to determine the voltage across another branch using the law of addition of voltages. Then apply law of addition of voltages. always in physics, whenever we need to mention the law that we are using. So how do I apply this law? We always write on the left the voltage of the battery, which is given by UPN, and on the right we will go we will write the voltages across different electric components, starting from the point P and ending with the point N. Then from P we'll go to the point A, then go to the point B, so from A to B, sorry, AB, plus now from B to C, and from C back to N. Okay, now let's replace the values. We have already, okay, UPN is equal to 10 given, UPA is equal to 0 justified, UAB that we need to calculate, we will keep it as a variable. Now UBC given to be 6 and UCN is equal to 0 already justified. Then 10 is equal to UAB plus 6. Therefore UAB is equal to 10 minus 6, which will give us 4. Now since 10 is in volts and 6 is in volts, then the voltage UAB will be in volts. Therefore UAB is equal to 4 volts. So the voltage UAB is equal to 4 volts. Now in number 4, they are telling me the lamps L1 and L2 have the same voltage, justify. Now notice that here the lamps L1 and L2 are in parallel because the terminal A of the lamp L1 is connected to the terminal A of the lamp L2, so they have the first terminal in common, and the other terminal of the lamp L1 is connected to the other terminal of the lamp L2, so this second terminal of the lamp L1 is connected to the second terminal of the lamp L2, therefore they have two terminals in common, which means that the lamps L1 and L2 are in parallel. Then first let's mention the groupings of the lamp L1 and L2. L1 and L2 are in parallel. And we know that whenever two electric components are in parallel, they have the same voltage, and this is given by law of uniqueness of current. So I repeat, whenever we always need to mention the law that we are using. Okay, so according to law of uniqueness of voltages, they have the same voltage, which is given by 4 volts. Now in part 5 they are telling me calculate the current I. So notice that here the main current I splits into two currents, I1 and I2. Therefore the current I is equal to I1 plus I2, and this is given by law of addition of currents. So whenever we always need to measure to mention the law that we are using here, we are using the law of addition of currents. Apply law of addition of currents. So the main current I splits into two currents. I is equal to I1 plus I2, and the value of I1 is given to be 0.5 amperes, so 0.5, and the value of I2 is given by 0.25, so this will give us 0.75. Since 0.5 is in amperes and 0.25 is in amperes, then the value of I will be in amperes. So I is equal to 0.75 amperes. Now in number 6 they are telling me deduce the reading of the ammeter, and the word deduced means that we need to use the part just previously before. In number 5 we have determined the value of the current I, which is given by 0.75 amperes. And from the electric circuit we can see that the ammeter is measuring the current I, which is given by 0.75 amperes. So in this case the ammeter will indicate either positive 0.75 amperes or negative 0.75 amperes, and this depends on the connection of the COM terminal. Notice that the COM terminal is connected to the negative pole of the battery, therefore the ammeter will indicate positive reading. Then let's say since the COM terminal is connected to the positive pole, to the negative pole. Then the ammeter will indicate positive reading, which is given by plus 0.75 amperes. So this is it for exercise number 2. Now in exercise number 3, they are telling me document 3 shows an electric circuit that consists of 4 lamps, L1, L2, L3, and L4 that are connected to a dry cell of UPN is equal to 10 volts. So here the voltage of the battery is given by 10 volts. K is a closed switch and the ammeter A is of negligible resistance. Now given that UCD is equal to 2 volts, so the voltage across the lamp L3 is given by 2 volts. UEF is equal to 3 volts. Now the value of the electric current I, which is the main current in the electric circuit, is given by 1 amperes. And the value of the electric current I2 is equal to 0.25 amperes. Now in number 1, they are telling me UBC is equal to 0. So across B and C we have the ammeter. So the voltage across the ammeter is 0 because it is of negligible resistance. And then let's say the voltage across the ammeter is 0 because it is of negligible resistance. So this means that UBC is equal to 0. Now in number 2, they are telling me calculate the voltage UAB. So the voltage UAB, which is across the lamps L1 and L2. So UAB, which is the voltage across the lamps L1 and L2. Notice that in part 1 they have asked me about the voltage across a certain branch. So we should keep in mind that we might use this value in order to calculate the voltage across another branch later. And indeed, the voltage UAB can be calculated using the law of addition of voltages. Then apply law of addition of voltages. Always on the left we write the voltage of the battery, which is given by UPN, and on the right we will write the voltages across different electric components, starting from the point P and ending with the point M. So from P we will go to the point A, and from A we will go to the point B. From B we will go to the point C. From C we will go to the point D. From D we'll go to the point E. From E we'll go to the point F. And from F we reach back the point N. Now UPN is equal to 10, which is given. Now UPA is equal to 0, and this is because it's a connecting wire. Notice that we didn't justify previously that UPA is equal to 0 because it's a connecting wire. Then we must justify it here between the brackets. So it's sufficient to say that UPI is equal to 0, and the reason is given by connecting wire. Now UAB that we need to calculate. Now UBC is equal to 0, already justified. Now UCD is equal to 2, which is given. Now UDE is equal to 0, and this is because it is a closed switch. Notice that we didn't justify why UD is equal to 0. Then here between the brackets we must write that UDE is equal to 0, and the reason is given by closed switch. So usually they give a half a mark for this statement and half a mark for this statement. Moreover, now the voltage UEF is given by 3 and the voltage UFN is equal to 0, and the reason why UFN is equal to 0, we didn't justify previously why UFN is equal to 0, so here between brackets we must write UFN is equal to 0, and the reason is given by connecting wire. Now tan is equal to UAB plus 5, therefore the value of UAB is given by tan minus 5. Since tan is in volts and 5 is in volts, then the value of UAB will be 5 volts. So UAB is equal to 5 volts. Now in number 3, they are telling me the lamps L1 and L2 have the same voltage. Justify. Notice that the lamps L1 and L2 are in parallel, because the first terminal of the lamp L1 is connected to the first terminal of the lamp L2, and the other terminal of the lamp L1 is connected to the other terminal of the L2. So both the lamps L1 and L2 have two terminals in common, therefore they are in parallel. And whenever two electric components are in parallel, we know that according to law of uniqueness of voltages, they have the same voltage. So the lamp L1 and L2 are in parallel. Then according to law of uniqueness of voltages, they have the same voltage. So they give half a mark for mentioning the law. Always in physics we need to mention the law that we are using, and the voltage is given by UAB, which is equal to 5 volts. Now in number 4, they are telling me determine the value of the current I1. Notice that here the main current I splits into two current, and they are given by I1, which is the current traversing the lamp L1, and the current I2, which is traversing the lamp L2. Therefore, according to law of addition of currents, then apply law of addition of currents. The main current I is equal to the sum of the currents I1 and I2. Knowing that the value of the current I is equal to 1, I1 that we need to calculate, and I2 is given by 0.25, then the value of I1 is given by 1 minus 0.25, which is equal to 0.75. Since 1 is in amperes and 0.25 is amperes, then the value of I will be in amperes. So I1, the value of the current I1 is equal to 0.75 amperes. Now in number 5, they are telling me give the reading of the ammeter. So the ammeter here is measuring the value of the main current I, which is already given 1 amperes. Now here the ammeter will indicate either positive 1 ampere or negative 1 ampere, and this depends on the connection of the COM terminal. Notice that the COM terminal in this case is connected to the positive pole. So the COM terminal is connected to the positive pole of the battery, which means it will indicate negative reading. Then let's say since the COM terminal is connected to the positive pole, then the ammeter will indicate negative reading. So it will indicate minus 1 amperes. And now in number 6, they are telling me the lamps L3 and L4 are traversed by the same current. Justify. Notice that here the lamp L3 and K and the closest switch K are in series because they have one terminal in common, which is the point T. And L4 and K are in series because they have one terminal in common, which is the point E. So L3 and the closed switch are in series. L4 and K are in series, which means that L3 and L4 are in series. So L3 and L4 are in series. And we know that whenever two electric components are in series, according to law of uniqueness of currents, they have the same current. I repeat, always in physics we need to mention the law that we are using. They have the same current. And now, make sure, okay. And now an exercise for they are telling me the electric circuit of document 4. They mentioned the document, so now I can use it. Consists of 4 lamps that are given by L1, L2, L3 and L4 connected to DC voltage source of 24 volts. So the voltage of the battery is given by 24 volts. An ammeter is connected in series with the lamp L2 and K is close the switch. The given ammeter is of negligible resistance. Given that UAB is equal to 10 volts, UFG is equal to 6 volts, and the value of the current I1 is equal to 0.75 amperes, and I3 is equal to 0.5 amperes. Now in number 1 they are telling me UPA is equal to UBC is equal to 0, justify. So across P and A we have a connecting wire, and across P and C we have a connecting wire, and we know that the voltage across a connecting wire is always 0. The voltage across a connecting wire is 0. So UPA is equal to UBC, which is equal to 0. Now in number 2 they are telling me UGN is equal to 0, and across the GNN we have a closed switch, and we know that the voltage across the closed switch is 0 because it acts as a connecting wire. So in this case UGN is equal to 0. Now in number 3 they are telling me UDE is equal to 0, justify. Across D and E we have the ammeter, and because it is of negligible resistance, then the voltage across the ammeter is 0. So the voltage across the ammeter is 0 because it is of negligible resistance. So UDE is equal to 0. Now in number 4 they are telling me calculate UCE across, okay, which is across the lamps L2 and the ammeter and the lamp L3. Notice that in parts 1, 2 and 3 they have asked me about the voltages across a certain branch. So this means that we will use these values later in order to calculate the voltage across another branch using the law of addition of voltages. Then let's write here apply law of addition of voltages. So on the left we will write the voltage of the battery, which is given by UPN, and on the right we will go over the voltages of different electric components starting from the point P ending to the point N. So UPA, from A we will go to the point B, and from B we will go to the point C, and from the point C, so here we have two cases: either we go to the point D or we go directly to the point E across the lamp L3. And notice that because they are asking me about the voltage UCE, so we will go to the point E directly across the lamp L3 plus UEF plus UFG plus UG back to N. So the value of UPN is equal to 24, which is given. Now UPA is equal to 0 justified. The value of UAB is given to be 10 plus UBC is equal to 0 justified. UCE that we need to calculate plus UEF is equal to 0, and here we write between brackets UEF is equal to 0, and the reason is given by connecting wire. Okay, and UFG is equal to 6, and UGN is equal to 0, close the switch, already justified. So this means that 24 is equal to the value of UCE plus 16, which means that the value of UCE is equal to 24 minus 16, which is equal to 8. Since 24 is in volts and 16 is in volts, then the value of UCE will be in volts. Therefore, UCE is equal to 8 volts. Now, this is it for part 4. Now in part 5 they are telling me show that UCD is equal to 8 volts. So here we will also apply the law of addition of voltages. So apply law of addition of voltages. Then on the left we write the voltage of the battery, which is given by UPN. And on the right we write the voltages across different electric components starting from the point P. Now here from the point C we can either go to D or to E directly, but since in part 5 they are asking me about UCD, then we will go from C to E across the point D. So UCD plus UDE plus UEF plus UFG and finally UGN. So this is G. Now the value of UPN is equal to 24, UPA is equal to 0 justified, UAB is equal to 10 justified, UBC is equal to 0 justified. Now UCD that we need to calculate, UDE is equal to 0 justified in number 3 plus UFG here. Okay, so UEF is equal to 0, we have justified in part 4, and UFG is equal to 6, and the value of UGN is equal to 0. UGN is equal to 0 justified in part 2. Then this will give us 24 is equal to UCD plus 16 So UCD is equal to 24 minus 16, which is equal to 8. Since both 24 and 16 are in volts, then the value of UCD will be in volts, which is given by 8 volts. So UCD is equal to 8 volts. Now finally in part 6, they are telling me determine the value of I2, which is the electric current traversing the lamp L2, and deduce the reading of the ammeters. So number 6, here notice that the main current is given by the current I1, which splits to two currents I1, I2 and I3. We know the value of I1 and we know the value of I3. Therefore, we can deduce the value of I2 using the law of addition of currents. So apply law of addition of currents. So the value of the current I1 is equal to I2 plus I3. The value of I1 is given by 0.75, whereas the value of I2 that we need to calculate plus I3, which is given by 0.5, then I2 is equal to 0.75 minus 0.5. This will give us 0.25. Since 0.75 is in amperes and 0.5 is in ampere, then the value of I2 will be in amperes. So I2 is equal to 0.25 amperes. Now in the same part of this question, which is part 6, they are telling me deduce the reading of the ammeter, and deduce, that means we need to use just the thing before, which is the value of I2. Notice that here the ammeter is measuring the value of I2, which is given by 0.25 amperes. And in this case, the ammeter will either indicate positive 0.25 or negative 0.25, and this depends on the connection of the COM terminal. Notice that here the COM terminal is connected to the negative pole, therefore the ammeter will indicate positive reading. Now let's say since the COM terminal is connected to the negative pole, then the ammeter will indicate positive reading. So in this case, a plus 0.25 ampere. So that's it for me in this video, guys. And in the next part, we'll complete the explanation of this chapter.